A new eye has opened on the universe, and we are seeing the heavens for the first time all over again. The James Webb Space Telescope, a magnificent golden honeycomb, floating 1,000,000 miles from Earth, close-up of the mirror and sunshield. It is not just an upgrade to what came before, it is a fundamental shift in our perception of reality. It is a time machine. It is a ghost hunter. It can see light that traveled over 13 billion years. It peers through cosmic dust clouds that hid secrets for eons. Webb operates in infrared, a wavelength invisible to our eyes. Think of a bustling city at night. You see bright lights of buildings and streets. An infrared camera sees heat, engines, homes, people. Webb does the same for the cosmos. It looks past the dazzling glare of nearby stars. One of the most profound revelations from Webb comes from its deep field images. It stares at a tiny, seemingly empty patch of sky for hours on end, collecting every last photon of ancient light. In these cosmic core samples, Webb has found galaxies far more developed and mature than our theories predicted for that early epoch. We expected small, clumpy, disorganized collections of stars. Instead, some already possess structure and brightness, and a surprising abundance of heavy elements. It is like looking at an early Earth photo and finding complex cities already built. This forces a major rethink. Early galaxies built stars at a furious pace, churning out massive, bright stars that lived fast and died young, seeding space with carbon, oxygen, neon, building blocks of planets and life. It is like a forest, where towering trees seem to spring up almost overnight. We are missing a key ingredient. How did matter gather and star formation supercharge so quickly? For decades, we have seen stellar nurseries, vast clouds where stars are born. Hubble showed beautiful, ethereal clouds, but Webb's infrared vision pulls back opaque veils of dust. We now see intricate filaments, bubbles, and pillars sculpted by newborn stars. It is like seeing the skeleton of a creature we once only guessed at. Webb reveals protostars, infant suns wrapped in dusty cocoons. We see jets and powerful outflows carving canyons in gas. We detect the faint heat of accretion disks, cradles of planets, the pillars of creation, transformed from solid mountains into translucent, ghostly tendrils, a revelation. Within them, bright red glows of newborn stars still hidden inside. We are watching a sacred act of cosmic birth, the cycle of birth, life, and death. Environment shapes planets, radiation, metals, and density matter. It is really a beautiful thing to witness. Perhaps the most exciting capability is studying exoplanet atmospheres, using a clever technique called transit spectroscopy. When a planet passes in front of its star, a tiny fraction of starlight filters through its air. Webb captures that light and breaks it into a spectrum, revealing a unique chemical fingerprint. We are now reading the air of other worlds, clear evidence of water vapor, carbon dioxide, and silicate clouds. Next, Webb turns to smaller rocky planets in the habitable zone, the Goldilocks region for liquid water. It will stare for dozens, even hundreds of hours, stacking signals to tease out faint chemistry. We are searching for biosignatures, gases hard to explain without life. Finding them would not be definitive proof, but it would be compelling evidence we are not alone. Webb has turned the search for life into observable, data-driven science. Beyond chemistry, Webb is giving us our first look at alien weather. By observing planets over their full orbit, phase curves map day-to-night temperatures. On hot Jupiters, the hottest point is often shifted eastward, a sign of supersonic winds. Winds whip through upper atmospheres, dragging heat with them. Imagine clouds of vaporized rock and iron sweeping from day to night. Webb is not imagining these climates. It is measuring them. Those measurements refine sophisticated climate models for extreme worlds. Exoplanets are a natural laboratory to test theories beyond our solar system. It is like a mechanic learning from a Formula One engine. Extremes teach fundamentals. Composition is not enough. Climate and weather determine true habitability. A right orbit world can still be barren, runaway greenhouse, or too thin air. Webb's climate details will help sort Earth-like candidates from imposters and pinpoint worlds with the right ingredients and conditions. Webb also turns inward, revealing our solar system in new detail. Jupiter's turbulent atmosphere, faint rings, and polar auroras glow in infrared. Uranus and Neptune come into sharp focus, rings and fast-moving storms unveiled. Webb can analyze faint water plumes from icy moons, hunting subsurface oceans. It studies small, faint bodies, cosmic fossils that preserve our system's origins. Colors and compositions trace the formation and migration of planets. With every discovery, Webb teaches humility. Early galaxies too big, atmospheres too strange, structures too intricate. There is a powerful emotional resonance in these images. We are seeing the raw materials from which we are made. Stardust, the iron in our blood, the oxygen we breathe, forged in ancient stars. Our planet is a tiny, fragile oasis in a vast, ancient universe. The invitation is open to all. Keep looking up. The journey has just begun, and Webb will keep peering deeper, tasting alien air and uncovering the unimaginable.